right? But those are the people talking when the computer was introduced when they were in their 20s and 30s, you know, so they had to learn by hand. So they welcome, guys. This is a dive live. Like I mentioned before, this are 20-minute presentations, 20 to 30 hosted on the Sunken Blimp Stage. And we're currently on our second week of the dive live series called Creative AI, where we're talking about the field of artificial intelligence and creativity, design, etc. Today we have a very special guest with us, Carlos Navarro. And for those that don't know, Carlos, he holds a master's of design research from the Southern California Institute of Architecture and a diploma of architecture from the Ponthifical Catholic University of Peru. He is an architectural designer with his work background from firms in Los Angeles and Lima, and his work has been published on digital platforms such as Art Daily, Frame, Architect Magazine, The Architect's Newspaper, and some others. He has also participated in the jury panels of Otis College of Art and Design in LA and computational design workshops in Lima. And he has taught computational design courses in Universidad de los Andes in Bogota. Today, Carlos shares with the community his research with neural network-based image generation models and explores their potential agency for volumetric reconstructions in the hope of superseding manual 3D modeling and the architecture form-finding processes. So thank you, Carlos, so much for being here. We're super excited, and the stage is yours. Take it away.
Great. Thank you, Mateo. Thank you very much. I'll make sure that the screen looks okay. Yeah, it looks fine. Okay. Thank you, Mateus. Thank you for having me, Sunken Blimp, for inviting me to share my work. I'm very happy to be presenting here today in this series that includes such great personalities from our field. And the stage looks amazing. Thank you so much for helping to lay it out. Okay, I'll start with a brief introduction of my background. I'm an architectural designer based in Los Angeles, California, and currently I work as a project designer at Office Untitled. I come from a traditional architectural background. I had a traditional but progressive architectural formation at PUCP in Peru, where I was taught by some of the best emerging practices from Latin America in those years, namely 511, Barclay and Cruz. So while practicing for some years at my studio in Lima, I started to identify and become interested in operating in areas that challenge the established boundaries of our discipline and converse more with other industries such as computer science, digital design, interactivity, and XR. So that prompted me to take the Architectural Technologies Master's Program at SciArc in 2015. And since then, as you can see in the screen in my portfolio and website, aside from my work as a project designer, but often in conjunction to it, for some projects, I work as an architectural technologist, developing research, most recently in AI and machine learning, which I've had the opportunity to divulge during the past and present year at conferences such as Digital Futures, One Planet, the Cadria Post-Carbon Conference, and again, Digital Futures 2022 summer event. So we'll be talking about these three topics today, which carried out 3 explorations. And the first one is going to be sorry. Oh, and this came from this come from a research that I developed during the past year in 2021, that evolved into this final research opportunities that became eventually workshops. So there's a project called Tower GAN based on 3D GAN, Perplexity in TSNE machine learning model, which was developed in a workshop that I took in 2021. And then a couple of projects into agent mobility and metaverse called AI sprawl and attention economy. So the first project, which is GAN's digital form of matter, it's a study on architectural typologies to latent space that became a digital filters tutorial. It's actually online and you can access it. The case study were 3D GAN, digital materiality, and NFTs. It started with a project called Tower GAN, and I want to credit George Juida here, because this is a project that I developed in one of his workshops, and I am very happy to share that with you, as well as Runje Tian and Dongyun Kim. And this was a project that I developed with Shifei Shu. This is very briefly a project about a tower that was generated with a couple of AI workflows. 3D GAN, which is 3D VAE GAN, which uses Python for generating for training point clouds through 3D model dataset, and also the typical style GAN that was used for texture mapping. As you can see in this slide, the 2D style GAN was used for generating floor plans, and then some animated sections of the latent walk were used to generate the core. So you can see these two exhibits here, the final outcome of that style GAN model that was produced with a very large dataset of SAT typologies, and then as you can see here, the training process of the 3D AE GAN, which was an actual 3D GAN training in Python. So from this first exploration, I became really interested in what the latent space was in an AI model, which is this interpolation of data or image from one image to another. And I started to understand that as a fluid matter, computational matter that I could actually sculpt in a volumetric manner. This project right here was called Billboard GAN. It's a project that I started at Office Untitled for a Billboard project that was on the site of a building of the architect Oscar Niemeyer. So we decided to explore or train a model with a data set from his architectural style. So a large collection of images of arches were gathered, and eventually a style GAN model was developed, which was then used to generate this form, generate this animated object that could help us to extract specific moments, specific sections that we could reuse as design options. This was again a 2D GAN of the animated latent space, and style transfer of Monet was used to texturize. And then, as you can see here, some of the design options that were able to be generated with this workflow. So from these first explorations that I started with in Grasshopper, I continued with the idea of three-dimensionalizing this collection of images, this series of videos, these interpolations of images that you could generate, because I became really interested in the fact that you could generate images from two poles and actually find new things that you wouldn't imagine. So this project here called again the GAN digital form of matter. I named it ArcoGAN, and it was a study about arches, in which the compositional agency of the arch had historically fluctuated between order and subversion. So architectural imagery of this compositional range that has been extensively documented on multiple mediums throughout history made a good case study for machine learning. This is an image of the data set that was used to for the study of these arches, and it undertook the three-dimensionalization of this 2D GAN, produce latent imagery through a series of workflows that engage dataset as an animated computable matter from which to use specific cross sections or moments again, ultimately defining the questioning or questioning the designer's role in the AI design process. An augmented data set developed with Python, from which we were able to actually train the model and extract a series of checkpoints. And from this series of checkpoints, a video, a stallion was generated. And this is a snapshot of all the 444 frames that were developed from those 4 checkpoints that were then used to animate and generate these objects and explore the digital materiality of this latent space through the typical, the typical resources that we have available right now in digital culture, like point clouds, voxels, pipes, blobs. So these exhibits search to operate between the most trending digitized mediums, embracing the instrumentality of social media and NFT culture in AI and current architectural representation. So curated orthographic views, aspect ratios, and duration determine the ontology of each animated exhibit. And a series of 3D aggregative superabundance methods are carried out on the GAN model as a means of speculating on a digital materiality that confronts density and texture with motion and duration. So animated turntables and frontal elevations views are used to portray the vastitude of potential outcomes of these 3D GAN models. And then finalized design options are ultimately extracted from the GAN based on relatable new typologies, engaging the compositional instrumentality of the original arch facade dataset. So that was the first project, and you can see the exhibits to your right. You're welcome to walk around it. Part 2 is material intelligence in the circular economy, the end of waste. And this was a project that explored the agency of neural networks in the study of material stages. It was a workshop that I held at the CADRIA 2022 Post-Carbon Conference. And the case study was 3D GAN, digital materiality, circular economy. And I did it with a good friend of mine, the GSL. And this started, or this was somehow derived from a workshop that I attended again in 2021, held by Sang-Yen Su and Seung-Min Han, and it was this exercise on perplexity and the TSNE model for a study on facade typologies to the TSNE model, and also the dataset augmentation with processing, which was actually the tool that I really engaged with more than the TSNE. But as you can see in these exhibits, a dataset of different facade typologies were gathered, but then augmented, which was something that I was very interested in because I didn't have to, gather again 1,000 images to generate a Stallion model. I could use a small amount of images and then just extrapolate and actually work with features that I was interested in. So again, this is the data set that I gather to generate this kind of rich images. Just 16 images, which was had a lot of potential. So going into the workshop again, it was a 2-part workshop that explored the agency of neural networks in the study of material stages within the context of life cycle assessment in the circular economy. It primarily focused on the use of GAN in Runway ML and Google Colab to identify new cradle-to-cradle generate opportunities within latent works from material life cycle image data gathered from conventional linear economy industries that may waste processes. This workshop engage the instrumentality of AI in recycling and closing life cycle loops, not only in terms of proper post-carbon waste management, but also in potential manufacturing approaches. So problematizing the styles and historicisms became pertinent again to define the contemporary in the post-digital. So using AI, using the AI style, surface richness, volumetric features, and unique outlines within a digital materiality sustained in economics, should help to orient that discussion. And these are final outcomes of the digital materials that were created from the data set gathered from, in this case, polyurethane foam. And then objects like this were able to be generated using Cinema 4D and the volumetric tools that it has, along with Houdini. But it was not only a static workflow. It was also an animated workflow in which, again to select cross sections of this latent space and choose the moments that could generate interesting architectural opportunities or interesting objects. So these are the hallucinations of the polyurethane transformation, passing from the state foam to the state dust. And again, the same process was replicated for other materials. In this case, for example, face masks were used, and also plastic polymers. Again, it was a compilation of images and extrapolation using processing to extract interesting features, and then the style guns were generated with this technique. Didn't play, but these are style guns. My PowerPoint closed. Give me 1 second. A very large PowerPoint, which I have here. I mean, large in size.
Perhaps, Carlos, if you like, you can show some of the work in the 3D models and the videos.
Sure, we can walk around. Let's do that. If you follow me, you can follow me in this board right here. We can see what I was explaining before, which the images on the top are just augmented data sets that we gather from 3 materials. Again, polyurethane foam, face masks, and plastic polymers. The script was used to augment them, and then the Stallion 2 AI model was used to generate interpolations between them and generate actual digital materials. So what you're seeing here are actually new images or hallucinated materials that don't exist. And afterwards, with the volumetric process made in Houdini and export we were able to inform architectural objects, just like these ones, as you can see here. If you follow me, you can see here that these objects were actually voxelized and informed by the materials that were developed with the software to generate these formal explorations, as you can see here. So again, erosion, a stage of decay of these architectural objects was kind of the premise, but not only just to erode them. Actually, it was used to generate a new kind of digital materiality, as you can see in these two videos here. Again, the point cloud and the animation features of Cinema 4D were exploited for this project because that's another thing that I am interested in. I mean, usually as architects we work in Rhino, and it's about generating geometry and about generating, let's say, buildable geometry or in the best case scenario, 3D printable geometry. But other industries have programs such as programs such as Houdini, Blender, or Cinema 4D. They are based in the digital. So all of this geometry that you see here, it doesn't actually exist, and that is why we can have just like tons of particles, tons of point clouds, tons of trails that we can use to generate new architectural form or generate this new digital design. So this is what I some of the briefs that I written for my workshops is what some of the things that I am interested in. It's the new economy of means of the digital materiality, digital design, and now of the AI. It's about switching gears from let's say the digital fabrication to the digital or the post-digital. And what these new tools allow us to generate, right? Okay, so this was a material intelligence project that we developed with Jia Zhao, and if you follow me downstairs now, we can see the next project, final project, which is the Performative AI. So follow me, please.
All right, guys, the tour is still downstairs now.
All right. Okay, so for this Performative AI workshop that was held recently in Digital Futures, and that I did in collaboration with my good friend Harry Moller, this piece that you see right here is the core of our exploration. I am moving this. It was basically an exploration in which you can pass from an image, an AI-generated image, and we use for these different kind of different AI models. Actually, we explored a lot of models. I started with Stalgan a year ago, but now there are just tons of AI models for image generation, and that is why I actually I haven't explored so much into those, because I just feel overwhelmed of how many AI models are there right now, and anyone can do just like beautiful, amazing images in a few steps. So we use the power of those image generation tools to generate architectural form, but then it was about three-dimensionalizing this and again explore the digital materiality, the possible digital materiality that we could extract from these objects. Maybe if we go around the room, you follow me here. This image is very illustrative of the process. If you look up, you're going to see 4 images that we took from an AI prompt made in Disco Diffusion, which was, and it was an AI prompt that was very specific. For example, we want to be able to circulate these geometries, so stairs, ramps, terraces, platforms, were words that were embedded into the prompt in order to generate images with enough walkable surface, because we wanted to actually engage the performative quality or agency of Unity, the Unity 3D engine or game engine to deploy ML agents. So as you can see, we passed from checkpoints in the Disco Diffusion AI model to depth maps generated with Midas, and then actual 3D meshes, as you can see here. These are actual three-dimensionalized images, and as you can see here, they are just planes. But we were able to work a script. If you look again at the model, we were able to work a script in Houdini to soften the actual geometry, and not only soften it, but actually being able to extract the subject of the image. As you can see in the image here, there's kind of this ziggurat geometry, and the sky was taken out, as well as some part of the foreground. So we could actually start to work with very two-dimensional images and less planar images, and then again just engage in the digital materiality of these surfaces. You can see to the right, to the left, sorry, where I am right now, some of the videos that we developed for the thank you, Mateos, that we developed for the workshop. It was about placing as much agents as we could in this game engine environment of actual 3D buildings generated from AI. So we work with six examples, and you can see that they are not static; they are actually animating, because the diffusion that was generated was actually used to animate or inform the actual action of these objects in the game engine. There's also this interesting video here that you can see. These are some of the outcomes of the workshop developed by great students, and as you can see, again, a lot of agent exploration and architectural form was developed. Maybe just to end the presentation, I'll share quickly again my PowerPoint to show a few more exhibits. Where is the share button? Share button. Okay, share screen. Okay. So I'll put it right here. This plant is.
I got it. Don't worry.
Okay.
Put it in place.
Great. Thank you very much, Mateus. Okay, so I wanted to show this exhibit here. In which, as you can see in the video, we are engaging again into the data sculpture theme to generate architecture. You know, these images are very relatable to whatever you see on Instagram today. Artists, digital artists such as Refik and Adol, that are very invested into data sculptures. And I find that, you know, with the exploration that I've been carrying out during past year and this year, that is it has a lot of potential for architecture. So you can see on the left the common video of the data sculpture, but actually today with the technology that we have, we are actually able to extract a subject from an image and making it 3D and making it a building. Or this is what this video is actually proposing tentatively. Yeah, so yeah, these are some images about the workshop presentation. But again, as I mentioned before, mainly two models were used: StyleGAN to the left and Disco Diffusion to the right, to generate the form exploration. And prompts were also very instrumental for this generation. And yeah, we actually explored a lot in the different outcomes from different models. Like, for example, this is Disco Diffusion. This is 9 of them were generated by the same prompt, which was just Zaha Hadid landscape design. You can see that the difference of outcomes that you are able to get today very easily. Some of these are paid models, but still they are very accessible. And then, for example, just changing the prompt a little bit, right? Like for example, in this case, some, let's say, cyberpunk style infill buildings in isometric view, and we change cyberpunk by Art Nouveau, Baroque, futuristic, and then making it 3D. So that's how we got an actual model from which we extracted all the frames, and then selected interesting frames that we could use to track depth maps. But they were not only static. I mean, with the AI models that we developed, we were able to actually generate the depth maps for a whole sequence of video, which allowed us to actually, generate animated transformations and diffusions, and engage in the material condition of this latent space and these morphing topologies. And recreate these environments for circulation, envisioning architecture in some manner, yeah. So ultimately, the performative agency of the latent space was studied in the search of morphing topologies that ML agents could learn from optimized mass navigation performance and program use simulation. You can see there the difference between mesh and point cloud, and all using the power of Unity VFX. Just as in Cinema 4D, in which we use the power of Redshift for rendering, we used in this case the power of the VFX tools in Unity to generate non-existing geometry or instances that could allow us to play just millions of information. Yeah, so the workshop's goal was to generate an autonomous architectural form-finding entity with control levels of supervision within a collaborative AI environment. That lied between the AI indeterminacy and the human control while challenging, again, the designer's role. As you can see in these videos. Yeah, and then these are some additional images in which we used, again, this diffusion to, for example, take an image from Midjourney and keep changing features. And these things are, they have better result now than 2 months ago with DALL-E 2. That I have to say that I haven't explored yet, even though I already have access to it. But examples like this where what we were looking for, like for example, in this case, we were passing from this first stage to a cyberpunk stage, or Baroque stage, or different stages. And then these are examples of these changes in the from just one first prompt that were done in Midjourney in this case. And again, some final videos of the game engine environment that we generated, and the difference between possible digital materialities, point clouds, and rails in this case, and the agents in action interacting with the buildings and with themselves also. Yeah, so thank you. That's it for the presentation. If you guys have questions, I'm happy to try to answer them. Thank you for your time. Thank you all.
No, so if anyone has any questions, feel free to ask. Oh, sorry, go ahead.
No, sorry. Go ahead.
Oh, I was just going to mention, if anyone has any questions, feel free to ask for, and then we're going to have a quick Q&A session. So you actually were ahead of me.
Oh, sorry.
I was wondering, well, all of these programs you mentioned, 3D GAN, Houdini, Midas, you had to actually program actually write the code for each one of those. Is that correct? Or it's like something the programming first, like an AI generated models, instead of just using the AI as an image prompt for the to then.
Could you repeat the first part of the question?
Yes,
because you cut out in the beginning.
Yes, of course. So I was wondering if you had to write, the scripts for each one of the programs to interpret the data, or if it was just something AI generated.
Different scripts were developed, definitely. What I can say that all of them have in common is the manipulation of the let's call the latent space, although it's not latent space for different AI models, but let's call it the latent space. So the manipulation of that volume is what all of these three exercises have in common. And for them, I use different workflows. Like in the first case, for example, we have, and I think we didn't actually walk around the first UIs wanna go. But I mean, you could watch it. We could go upstairs and, for example, look at the 3D GANs. Yeah, so these guys here, they were generated in Grasshopper, and And yeah, it had some Python scripts, some Python components that I developed in order to actually being able to extract some color information from the images that then allowed me to just make a simple mesh displacement. But yes, Python was used for the color manipulation of the images in this case. And then in the rest of the exercises, yeah, the Houdini script, I also had to research a lot to extract, to generate the volumes for all the materials. And then for the performative AI exercise, yeah, we actually developed a lot of scripting, C# scripting for the agents, as well as some scripting for the Houdini part of it, which was for the image, the subject extraction from the images. As you, but I mean, again, all the coding is not, I mean, you have an understanding of it, and you get better at it with time. But most of it is just, assembling parts that you can find online from people that have developed similar things.
Thank you, Carlos.
I actually have a question, Carlos. I would like to know your opinion. This theme of artificial intelligence, right? It always brings back the conversation about data and the importance about data selection. If we think about artificial intelligence as a little child that you're teaching, right? You're letting them see the world that you select for them to see, and then letting them, dream with the information that you give them. I'd like to know, thinking about the future of architecture, even, and the information that we feed to create these models. What is your perspective on the importance of inclusivity to create something? Thinking of the future, especially when we think about that majority of the images being generated right now, people are experimenting are the Zaha Hadids and Frank Gehry's, when in fact, majority of the world we live in and our needs for space, etc., are, they lie elsewhere as well. So I'd like to know your opinion on that portion of data selection.
Right. Thank you for this question. Yeah, it's very interesting. What I think is that it is an important matter. It is an important concern. I actually speaking something related recently with a friend that is also very invested in AI, and I think we have to be cautious with the information that we train the models with, because certain biases get developed. Certainly, as you said, in architecture, in terms of the style, it's Hadid, Gehry, the photorealism of Midjourney, against whatever architectural kind of representation that is taught in schools recently. So I think that yes, we have to be cautious with that. It's a concern, and that is why actually you can see in the news how the research in AI nowadays is trying to be controlled, trying to be limited. Because it is dangerous. You can see fake information on internet nowadays very often. So it's an interesting matter, and I can't say where I stand right now, because I am in pro of keep investigating and researching about this. I think it's great and we should do it, but there are things that are going to come along with these tools, with this information that we have to engage, right? Like, for example, the cases in Google in which they say that some AIs become sentient, things like that. And that is why I actually try to be more invested in my research into the actual application of these tools. I mean, not actually going that much into how good I am to generate images or to actually control the AI. But let's see how these new tools can inform the architectural representation, the architectural form finding, which can be useful for our industry.
Yeah, of course. And just a quick answer, a quick question actually. In your opinion, do you think this is going to replace the architect, at least the architect as we know today?
I think if it's not going to replace it, we're going to have to just work with it very, very closely, because these tools have come to stay, yes, and we have to engage them. That's the short answer.
Yeah. And I actually encourage, if anyone has any other questions about work, about his presentation, feel free to do so.
I have a question about, earlier you had mentioned some of the online resources you had used in creating the scripts that you made for these projects. Do you have a list of those resources, or do you have any plans of potentially open sourcing some of the work that you've done here?
Well, I am always in the lookout for just sharing the research through workshops and events. So I will definitely keep doing that. There are things online that you can see right now, like for example, the tutorial from GAN's Digital Form and Matter from Digital Futures. That's something that is online, and you can watch it. And then I'll just keep trying to sharing the work, and find new opportunities to explore new subjects. I have like many avenues that I want to keep exploring, and I will definitely continue to throw these kind of sessions in the future.
Awesome, thank you. I just Googled that, and it looks like an awesome tutorial.
You can follow me. You can follow my work on Instagram. I try to be very active on that. I mean, related to my work, or my website, which I put a little more content in it, although I have to update it. But yeah. Thank you, everyone. It's been great. It's been great to be in this platform and see all the work together. It's crazy how to, I never imagined to see, the GANs next to the objects made with material intelligence and all that. It's just a great platform to share the work, Mateos. Thank you.
Awesome, and thank you so much for the presentation. This was honestly great. Seeing everything here, and I've been seeing your work for quite some time, and then seeing you here and walking through the models, it hits different for sure. So yeah, thank you for the presentation. And also, if anyone has further questions or want to participate in this conversation, feel free to reach out to Carlos on his social media, on the Sunken Blimp Discord. The whole point of this is for us to share ideas, share presentations and work, but to keep a conversation flowing, inspire people, etc. And on the topic, I just want to mention real quick, on the topic of these presentations, right? This is the second week of the series Creative AI. Next week we have Neil Leach, who's a theorist and has an amazing presentation, and going to be talking about creativity, AI, Midjourney, etc. And then after we have Ahmed, who actually has been working with robotics and artificial intelligence, which is going to be super cool as well. And then after that, we have a gallery here on stage, and that's going to be a community gallery. So if you guys have experience with artificial intelligence, even Midjourney and text-to-image models, there is a submission that you can still do until the 15th of August. And you can submit your work. We're going to add it to the gallery. We're all going to be showing our own projects. So yeah, feel free to do so and join Discord and be there. But yeah, thank you so much, everyone, for being here. This was pretty cool. A lot of engaging people, super excited. And yeah, welcome to the Sunken Blimp Stage.
Yeah, thank you again, Mateos and Sunken Blimp, for the invitation. It's great. It was super fun to to present today. And I guess feel free to walk around the stage and see the videos, see the images. It's great to see them all laid out. Thank you.
Awesome. All right. Have a great Wednesday, everyone, and see you guys next week. And if you're interested in medicine, tomorrow there's a medical lecture as well. There's Dr. James is even here, who hosts the medical lectures on stage. So yeah, I'll see you guys either tomorrow or next week.